finding the nth term in a sequence. To find the nth term in the sequence, the first thing you need to do is come up with the equation that works for your sequence, and then use that equation to come up with the nth term, whatever number of term it is they're looking for. So here we have the arithmetic sequence -4, -1, 2, and 5. So the first thing we want to look at is find out what the common difference is. What are we doing when we go from -4 to -1, -1 to 2, and 2 to 5? It looks to me like we're adding 3 each time. Now that we know our common difference, we're going to use the general formula for the arithmetic sequence, which is a sub n equals a sub 1 plus something times d. So we decide, do we want n plus 1 or n minus 1? We always want to use our previous term to get to our next term. So we're going to put n minus 1. That means the number of term you're on minus 1. So in this case, we've got a sub 1 is our -4, that's our first term. 3 is our common difference, that's d. And we're going to use the distributive property to get rid of the parentheses. So we have -4 plus 3 times n minus 3. And simplifying that down, -4 minus 3 is -7. So you can have 3n minus 7 or -7 plus 3n. I think it looks better when you have the variable in the front, so I'm going to put 3n minus 7. Now that you have an equation to represent the arithmetic sequence, you can use it to find the other terms of the sequence, which is step 2. So we take our 3n minus 7, and we use the equation from part A, and we're going to find the 16th term in the arithmetic sequence. And 16 is our n. That's where we're going to put the 16. So we take 3n minus 7. We substitute 16 for n, so we get 3 times 16 minus 7. Multiply out, so 3 times 16 is 48, minus 7, simplified, is 41. So the 16th term in our sequence that starts at -4 goes to -1, 2, 5, 8, etc. It's going to keep going all the way to 41 and beyond. But the 16th term is the one they asked for, which is 41 in this case. So you write a sub 16 equals 41.